Hey, 8th graders, 2 lessons today. Lesson 7, comparing linear functions and graphs, and Lesson 8, graphs of simple, nonlinear functions. It really just never likes you, does it? Okay. I think that's the first one. All right. So Alan and Margot each drive from city A to city B, a distance of 147 miles. They take the same route and drive at constant speeds. Alan begins driving at 1:40 p.m. and arrives at City B at 4:15 p.m. Margot's trip from City A to City B can be described with the equation y equals 64x, where y is the distance traveled in miles and x is the time in minutes spent traveling. So we want to find out who gets from City A to City B faster. So break it down. A, B. My computer doesn't like me today. Okay, so it takes Alan 155 minutes to travel the 147 miles. So his constant rate is 147 over 155 miles per minute. Margot drives 64 miles per hour, 60 minutes. So therefore her constant rate is 64 over 60 miles per minute. So to determine who gets from City A to City B faster, we just need to compare their rates in miles per minute. Okay, so basically just to find out what gets them to be the same in the bottom, and then we would figure out what the difference is, and it turns out that 64/60th is faster, so Margot would get there faster. So next, you have recently begun researching phone billing plans. Phone company A charges a flat rate of $75 a month. A flat rate means that your bill will be $75 each month with no additional costs. The billing plan for phone company B is a linear function of the number of texts that you send that month. That is, the total cost of the bill changes each month depending on how many texts you send. The table below represents some inputs and the corresponding outputs that the function assigns. So here you have the chart: 50 texts out, $50. 150 texts out, $60. 200 texts, $65. 500, $95. So, still not liking me. I'm sorry, guys. Let's see if we can do it this way. So find the rate of change to determine the equation for B. So 60 minus 50 is the output, over 150 minus 50 is 0.1. So our equation, in y equals mx plus b form, x is 50, y is 50. 0.1 times 50, we find out what b is. B is 45. So in the first company, y equals 75. That's our equation. The second, y equals 0.1x plus 45. So we solve for x then. 75 equals 0.1x plus 45. We get x equals 300. So, until you get to 300, phone company B would be cheaper. But once you get past that, then phone company A would be cheaper. Okay, one way to determine if a function is linear or nonlinear is to inspect average rates of change using a table of values. If these average rates of change are not constant, then the function is not linear. Another way is to examine the graph of the function. If all the points in the graph do not lie on a common line, then the function is not linear. If the function is described by an equation different from one equivalent to y equals mx plus b, where some fixed values m and b, then the function is not linear. Okay, so 3 different ways there. So will it be linear or nonlinear? This will be the majority of your assignment. So y equals x in some way, shape, or form. Y equals mx plus b. The next one, it's not, because x is squared. So it's nonlinear. Same with the next one, x is cubed. The next one you could rearrange and it could be in y equals mx plus b form. And the bottom one, no. Okay, so now we're going to graph these. So first we have y equals x. It's a line. Next, we have y equals 2x squared minus x. There's also a second x. Y equals 2x squared minus x. So this is called a parabola. Okay, you'll learn more about those in algebra. Next, y equals 4x cubed. This is a squiggly line. How fun. Next, 3x plus 7y equals 8. 3x plus 7y equals 8. It's a line. And last was 3 over x equals y. So 3 divided by x equals y. Oops. Equals y. Okay, we also learn about these in algebra. So that's it for your lesson. Again, the majority of it will be, well, this is the function linear or nonlinear. Please ask questions if you have them. Do your best on the assignment and have a wonderful day.